So today you are going to be working on volume of spheres, cylinders, and cones. You probably want to go to the volume formulas review, which was one of the assignments listed for today as well. It goes through the formulas for the rectangular prism, which is the volume is the length times width times height. There's a video you can check out if you want to learn more. The volume of a triangular prism is base times height times the length divided by 2. The volume for a cylinder is pi times the radius squared times the height. And again, here's the radius, and there's the height. Then finally, a pyramid, which is length times width times height divided by 3, and a cone, which is pi times the radius squared times the height divided by 3. And again, there's a video. So today's assignment, volume of cylinders, spheres, and cones. Zoom this in a little bit. So it says a cake decorator rolls a piece of stiff paper to form a cone. She cuts off the tip of the cone and uses it as a funnel to pour decorative sprinkles into small containers. The cone has a radius of 6 centimeters and a height of 18 centimeters. What is the volume of the cone before the end is cut off? So again, it's 1/3 times pi times the radius squared times the height. Volume of cone. So volume equals pi times radius squared times height, and then they do divide by 3. So you could actually type this in and use these, and it'll give you your answers. I'm going to go and show using the graphing calculator again. So it's going to be pi 3.14 times the radius. In this case, they told us to use 3.14 for pi, which was 6. Times 6 again for r squared, times the height, which was 18. And then again, according to the formula, we have to make sure that we divide that by 3. So divided by 3. And there's our answer. And they want the answer, it says give an exact answer. All right, so it's going to be 678.24. Okay, next question. A French fry stand at the fair serves their fries in paper cones. The cones have a radius of 2 inches and a height of 6 inches. It is a challenge to fill the narrow cones with their long fries. They want to use new cones that have the same volume as their existing cones, but a larger radius of 4. What will be the height of the new cone? Okay, so what we need to do here is we need to figure out what will be they want the same exact volume, and then they want a larger radius of 4 inches. So what we need to do here is we need to first find the volume. So radius of 2 and a height of 6. To make it faster, I'm just going to do this. So radius of 2, height of 6, because it's 25.13. So 25.13 is how much our volume is for the original one, the original cone here, okay? So for the other one, they want to have that same volume, but have a larger radius of 4 inches. So I'm going to attempt to do some writing on here. So we have 25.13 0.13 that has to be equal to pi, the volume of a cone. Try to show that again. Pi times radius squared times height divided by 3. Pi times radius squared times height. I'm going to show divide by 3. So what we're going to want to do first is we need to figure out what the answer would be in this case for h. They want us to solve for h. So first of all, we want to get rid of the 3 in the bottom. So we're going to cross multiply. So if we cross multiply, that's going to be 25.13 times 3. So 25.13 times 3. That's going to give us 75.39. Okay, so that's going to be 75.39. What we need to do is we have to get rid of the pi, and we have to get rid of the r squared. So they're telling us that r is going to be 4. So this is actually going to be 4 squared, which is 16. So what we want to do here is this is 75.39 is equal to 16 pi times h. So we need to divide both sides by 16 pi. So we want to divide this by 16 pi. They didn't tell us what exactly to use, so I'm going to actually just do 16 pi. So 75.39 divided by 16 pi should give us a height of 1.4998. So I rounded that to 1.50. 1.50 inches would be our new height. All right, now it looks like we have half of a sphere. So a fruit bowl is shaped like half of a sphere. The radius of the bowl is 15. What is the volume of the bowl? They tell us to use 3.14 for pi or an exact answer using pi. So the radius is 15. We want to do half of a sphere. So again, pull up the formula so you can see it. So the volume of a sphere formula is 4/3 pi times the radius cubed. And then we need to divide that by 2 because we only have the bottom part. Okay, and again, you could just type it in here what the radius is and it would solve it, but I'm going to use the calculator. So 4/3 times, and I'm going to do 3.14 for pi, times the radius of our problem to the third power, which is 15. So we're going to do times 15 times 15 times 15 for the third power. That would be the volume of a whole sphere. We don't have a whole sphere, we have half. So we need to then divide that by 2. And when we do that, we get 7065. Okay, cylinder problem. The Ming family has a backyard kiddie pool with the dimensions shown. After a lot of splashing one afternoon, the pool is only half full. So the pool's half the amount full. What is the volume of water remaining in the pool? Okay, so if this is the original pool, which is 4 feet for the radius, height of 2, we need to find the volume of this cylinder, but we want the volume of the water, so we need to then take half of that amount. So volume of a cylinder Again, we could just plug in the numbers here for the radius and the height, and it would find it out for us. But I'm going to again show it on the calculator. So for pi, again, we can use 3.14 times the radius squared. So the radius here is 4. So we're going to do 4 times 4 for radius squared times the height, which was 2. And that would be the volume if the whole pool was filled. So they told us that it was only half full. So we have to divide that by 2. So 50.24. And then the units are cubed because of volume. So 50.24. And there we go. So hopefully this video helped you out if you were struggling with finding the volume of cylinders, spheres, and cones.